Okay, our goal here is to get really good at factoring. All right, let's go back to basics. When you learned arithmetic, factors of 10 are 2 and 5. Factors of 21 are 3 and 7. Why? Because 2 times 5 gives you 10. Why here? Because 3 times 7 gives you 21. Think through what makes a factor. Ask yourself, could 15 be factored as 4 times 5? No way. Why? Because when you multiply, you don't get what you started with. That's your basics of factoring. So let's bring it into an algebraic context. What if you were asked, which is the correct set of factors for x squared plus 6x plus 8, the left or the right ones? And just that quickly, you should be able to say the right ones. Why? Because when you multiply, you get what you started with. Over here, I would get x squared plus 5x plus 6, and that's not what I started with. Take a look at another one with a coefficient on the x squared. Would I like the orange or the blue or the green factors here? What you're doing is multiplying in your head. Here I would get 2x squared plus 9x minus 5. Here I would get 2x squared minus 9x minus 5. What's wrong? The middle term isn't what I want. Here I would get 2x squared. You can think plus 2x minus 5x. There's the minus 3 I wanted in the middle. Okay, the green ones work here because when you multiply, you get what you started with. If you're not good at multiplying, honestly, you just need to practice. It's a skill you have to be strong at, and it's something you can all get better at. Let's practice just basic ones here. I want to be able to say x squared. Now, some people still say minus 7x plus 3x minus 21, but your goal is just to be able to combine that middle term and do it in one step. Make that your goal, to be able to do it in one step. Here I might say x squared plus 3x minus 40. Some people like to do the lines as if you're foiling for the outer times the inner. It helps them to see what's happening a little bit easier. Those lines are especially helpful when you have coefficient on the x term. Here I would get 2x squared at the front, 15 at the back. That should be the easy one. I have a 10 and a 3, so I have a plus 13x in the middle. Get good at foiling so that you can always check as you go. Now let's dive in. First thing you are always going to look for is going to be something that is common to both, the greatest common factor. And in the first one, I have a 5 that's common. I pull it out and I have an x plus 3. Why does that work? Because when I distribute it back in, I would get 5x and 15. It has to multiply to get what you started with. Middle example, I have a common 2. Pull it out and I'd have an x minus 7. Third example, I could pull out a 3, but I could also pull out an x. Remember to pull out everything that's common. I'd be left with an x plus 2. And you can check, when I distribute, I would get my 3x squared plus 6x done. Now, there are patterns that we just have to learn, and one of the easiest and most comfortable ones for students is usually the difference of two squares, where you can break it down into x plus 3 as x minus 3. On 49, I'm thinking, what's its square root? X plus 7, x minus 7. All right, does it matter if I always do the plus first and the minus second? Not at all. With 81, I might say x minus 9, x plus 9. The order of the factors isn't important. If I had x squared minus 25, I'd have x plus 5, x minus 5. Now, wait a minute, where's that middle term going, you might ask? Okay, think about what happens if you were to multiply everything out. The middle term goes away because those terms add up to 0. So it does in fact check. The red is just checking. All right, keep going. Factor x squared plus 25. That's right, you can't because there's a plus sign there. It's prime. Remember, it's called a difference subtraction. Difference of two squares for a reason. Once you see the plus sign, stop. You're not going to be able to factor it. And of course, you have to put everything together. What was the first thing we said we're always going to look for? Oh yeah, GCF. So always look for that. If I pulled out a 2, I would be left with x squared minus 16, but don't stop. The beauty of these problems is sometimes you can go a step further because there might be a difference of two squares hidden in there. If you can go further, go ahead and do it. Now let's look at the more classic ones. Trinomials, 3 terms. What's nice about all of these is that you have a positive last term. And quite honestly, do you see a negative sign anywhere? No. And that helps you as you start. What's also nice is that I picked prime numbers here. 1 and 7 are the only factors of 7. I start off with x and x. I have to have a 7 and a 1 here. Why does that work? Because when I multiply, I get x squared plus 1 plus 7, so it's plus 8x plus 7. It checks. On the next one, I'm thinking of factors of 11. Well, there's only one choice there. I need to get that x squared in the front, so I start with x and x. I know I'm going to have all plus signs, 1 and 11. If I have 5, I'm looking at 1 and 5. It is prime. That makes me happy. So I start off with 1 and x, plus signs everywhere, 1 and 5. Then I have to get to the ones where I think a little bit more. Anticipate what's going to happen. I know I'm going to start with x and x because that's how I get my x squared. Do I want to do a 2 and a 4 or an 8 and a 1 if I'm trying to get a 6? That's right, I'm going to go with the 2 and the 4 so that when I multiply those all together, I end up getting the answer that I want. All plus signs, all plus signs. Notice that compared to these. Now what's nice here is that the last term is positive in all these. I'm just looking at the sign there, but all of the middle terms here are negative. And that's giving me a hint about the signs before I even dive into this problem. I know every problem on this page has to be a negative times a negative gives me a positive. Think about what you're doing when you multiply and you can anticipate that. Now, I have to work a little harder. I don't know if I want a 1 and a 4 or a 2 and a 2. Think about how you're going to get that negative 5 in the middle. It's going to be the 1 and the 4. Factors of 5, again, it's prime, makes me happy. So that should be an easier one. 12, a little bit of work to do there. I don't know if I'm going to want to work with 1 and 12 or 2 and 6 or 3 and 4. I don't need to write this down. That's just part of my thought process. But how am I going to get that 7? Oh yeah, the 3 and the 4 would help me with it. Next problem has a special pattern. We're going to look more at ones like these. If I'm asking myself, do I want 1 and 25 or 5 and 5? Think about how we're going to get that minus 10 in the middle. You're right, it's 5 and 5. And do you notice anything special about those? They're the same. There's a second way that you can write that. You can write it as the quantity x minus 5 squared. And that's a special family of problems we're going to look at next. They're called perfect square trinomials. Look at 14 and 49. Nice number between them would be a 7. 7 squared is 49. 2 times 7 is 14. Now, you might dive into the problem and not see a pattern. Simply factors of 49 that give me 14 are 7 and 7, all plus signs. Oh, okay, there is a pattern there. I can see it. It's a perfect square trinomial. It factors into the same thing by itself. Nice number between 36 and 12. Yeah, it's 6. I have a plus sign here, so I'm going to have a plus sign in my factor. Next problem, nice number between 16 and 64. Yeah, you got it. It's 8, and I need to match that sign in the middle. It's x minus 8 quantity squared. Nice number between 9 and 6, which is going to double to get me 6, squared to get me 9. Oh yeah, it's 3. Need to match that sign, so this is x plus 3 quantity squared. The special term is it's a perfect square trinomial. It's just a pattern that if you recognize, helps you with some factoring problems later on. All right, next set of problems, the ones we have to work a little bit more for. Now I no longer have my positive last sign, so I'm going to have to work on these. As I look at all these problems, I'm just going to dive in. I know I start with x and x to get x squared. I'm asking myself, do I want 1 and 18 or 2 and 9 or 3 and 6? How will I get that 7 in the middle? Which factors are 7 apart? You got it, 2 and 9. Now watch the sign. The larger number, in this case the 9, is going to match the sign in the middle. I have minus 9 plus 2 gives me my minus 7. Next problem, I'm diving in. There's no GCF. I have x and x. Do I want to work with 1 and 10 or 2 and 5 in order to get that 3? You got it. I need the 2 and the 5. The larger number is going to match the plus sign. I've got it. Going to take a look at 12. Notice both bottom problems work with 12. So I'm going to consider 1 and 12, 2 and 6, 3 and 4 as what to put last in my parentheses, factors of 12. In this case, if you just see a minus x, you're thinking minus 1 in your head. So which factors are 1 apart? The 3 and 4. The larger number, the 4, will match this sign. Okay, over here, I want now factors that are 4 apart. Factors of 12 that are 4 apart. Ah, there it is, 2 and 6. So the 2 and the 6 go in. The larger number will match the sign in the middle. And again, if you need to check, you should be able to do it in your head, but what you're thinking is plus 6 minus 2, oh yeah, there's the plus 4x, negative 2 times positive 6, negative 12. Last set of problems are the ones that we struggle with the most, but relax on them. I want you to feel comfortable and look for the prime numbers. In all of these problems, you might look to this lower left one and be the easiest because the only factors of 3x squared are 3x and x. So at least you know how to start those parentheses. But also nice is 5. 5 is prime, and I love it when I see a prime last term because I know the only options are 1 and 5. So if I were to dive into this, maybe I put the 5 here and the 1 here, and there's a reason we use pencil. If I were to check this, I would check it and say there's 3x and 5x, that gives me an 8x in the middle. Am I right? No. Not a big deal. You take your eraser and you go try the other combination. Well, what do you mean by other combination? It means you put them in a different place. So what if I had this as my plus 1 and this is my plus 5? Then I have my 15 and 1 and it checks. So what else is nice? Let's go up to the top one. I like 1 because it's prime. So in this case, I'm not sure how to start. I don't know if I want a 6x and an x or a 2x and a 3x. But I know I have to end with a plus 1, plus 1. Look at it, it's plus signs everywhere. Ask myself, how will I get that 7 in the middle? Will the 2 and the 3 do it? No, they'll give me 5. Will the 6 and the 1 do it? Yep, done. Over here, the upper right-hand example, there is a nice pattern here, and I do like that I have a 1. I know because 1 is positive here, but there's a negative in the middle. I'm going to have a negative 1 times a negative 1. And I need to think, how will I get that 6? Do I want to use 9x and x or 3x and 3x? Which combination will give me the 6? You're anticipating what will happen when you FOIL. What makes you happy? Yep, you got it. In this case, it's going to be the 3x and the 3x. Now look, you might not have seen it ahead of time, but you do in fact have the same factor twice. So you could write that as the quantity 3x minus 1 squared. And you can dive into these all day, but when I take a look at the last example, what is it, review, that I always look for first? Something common. Is there something common in the last example? Yep, it's a 2. If you see all even numbers, always go and pull that 2 out. And when I'm left with something, this isn't factorable, I'm done. So don't overkill problems, but have some fun with it. Don't take up too much space. And when in doubt, just multiply and see if you get what you started with. Good luck, guys.